Welcome to class. In today's class, we are going to be looking at the 2024 Physics JAMB past questions, the extracted or the consolidated questions, precisely. So we're going to be looking at questions number 2 to questions number 40. Discretion. These questions were extracted according to the type that was made available. It is not necessarily holistic as per some persons may have not seen some of these questions. This is just a random questions taken from the question bank for this given year. So in my last class, we looked at question number 1, which had to do with Lami's theorem. In this class, we are going to be continuing from question numbers 2. If you look at the comment section, you are going to see the questions displayed before you. If you are one of my students in the JAMB revision classes, you have the question in our WhatsApp group before you. You also have the hard copy before you. So you are going to be following each of these questions from the hard copy you have, from the soft copy you have, from what we have in the comment section. So we have 3 different places that you can have access to the questions we are going to treat. We begin from question number 2. I will still read it out for the benefit of those that may not have access to these 3 sources or may find any of these sources a bit cumbersome for them. Question number 2. Don't forget to like, don't forget to subscribe, don't forget to share. Thank you. Evaluate the frequency of the third harmonics of a closed pipe of length 0.3 meters. Speed of sound in air equals to 340 meters per second. So these are the options presented before you. In these particular questions, this question falls under a topic in sound wave called vibrations in air columns. If you watch my video on vibrations in air columns, you're going to see how some of the formulas that we're going to be using in this question were derived. So for the sake of this question, we're going to go straight to making use of these formulas. All right. So to start with, all right, we are required for the third harmonics. For a closed pipe, the length of a closed pipe is given as lambda over 4. That means that if you make lambda the subject of formula, lambda is given as 4L. That is to tell you that V is equals to F lambda, and by implication, that means this is a general formula that that F is equals to V over lambda. What did I just do here? I divided both sides by lambda. So we are finding the frequency. That is why I'm taking through this route. From here, we can say that since the length of a pipe is given as quarter of the wavelength. So for the first frequency, also called the fundamental frequency, all right, we say that FO is given as V over, remember the value of lambda? That was 4L. That was 4L. The series of derivations regarding this will be known or watched in that video. We need to answer this question. From there, for a closed pipe, we only have odd number overtones or harmonics. So this F is a fundamental frequency, and it is the first harmonics. Moving from there, I have 3FO. For a closed pipe, we don't have even number harmonics. We don't have even number harmonics. We have odd numbers. So 3FO simply means 3 times whatever FO was. That will be 3V all over 4L. 3V all over 4L. And the next is 5FO, that is 5V all over 4L. Alright? Okay, so let's correct a little bit of a mix-up there. This is the fundamental frequency. This is the fundamental frequency, alright, which is the first harmonics. This is 3 times the fundamental frequency. This is my second harmonics. Second harmonics. This is 5FO. This is my third harmonics. So this is the first overtone. First overtone. The second overtone, the third overtone rather, and this is the fifth overtone. I have first harmonics. My third overtone is the second harmonics. Alright? And my fifth overtone is the third harmonics. So you can quickly decide to pause the video and find the frequency of the third harmonics to see if you can spot your answer in the option. We continue. Moving there, we are going to have that the third harmonics is going to be not this one, but it will be this one. That's my third harmonics. So we have odd number. So don't get confused when we say that third harmonics is 5FO. Third harmonics is 5 times the fundamental frequency. Second harmonics is 3 times the fundamental frequency. First harmonics is that. So that is the harmonics that is present or that exists for a closed pipe. So third harmonics is 5FO, which is 5V all over 4L. We know what V is. V was 340 and L was 0.3. So quickly, 5 times 340 all over 4L. So 5 times 340, that gave us, if you use your calculator, all over 4L. Let me put 4L at once. 4 times 0.3. So 5 times 340 is going to give us that 1700. That is 1700. All over 4 times 0.3 is 1.2. So if you do that division very well, you are going to have 1416.66 hertz. That means 1416, approximately 7 hertz. That will be the third harmonic. So you can see that your answer is obviously A. We move to the next question. The third question says, an electrical appliance is rated 240 volts and 45 watts. Calculate the current drawn from the appliance. Calculate the current drawn from the appliance. Option A, 0.19 ampere. Option B, 0.30 ampere. Option C, 0.12 ampere. And option D, 0.45 ampere. So what will be the current? You have the question there with you? Alright. So moving from there, I want to find the current. Remember that I can say that power is equals to IV. There's another formula for power I can use, but this formula will be okay for me to do what I need to do. The power I was given was 45 watts equals to I times, this is 240. To find I divide both sides by 240, and 45 divided by 240 is 0.19 ampere. That will give you my current, or your current. And the correct option that you have before you there is option A. Option A, 0.19 ampere. So we keep moving forward, and we move to question number 4. Question number 4 says, I, engine oil, II, water, III, glycerin. In which of the following fluids will a ball experience the greatest speed? I, engine oil, II, water, III, glycerin. Which of the fluids which I have just mentioned will a ball experience the greatest speed? A, I only. B, I and II. C, II only. D, II and III. If you look at that question critically, you will see that of the 3 fluids being compared, engine oil is a viscous fluid. That's the internal friction between the molecules of the fluid is high. II is water. Water is not as viscous as engine oil compared to glycerin. The viscosity of a fluid is directly proportional, or is inversely proportional to the speed in which the ball is going to move in that fluid. A highly viscous liquid like engine oil and glycerin will drag the flow of ball. What I am trying to say is that a ball will experience the greatest speed in a least, or a fluid with low viscosity, that is not so viscous, and that fluid is water. Water is not as viscous as engine oil, not as viscous as glycerin. Remember, I, engine oil, II, water, III, glycerin. If you look at that question, the greatest speed will be the least viscous fluid. So the higher the viscosity, the slower the ball. The higher the viscosity, the slower the ball. The higher the viscosity, the slower the ball. Alright? So engine oil, high viscosity, the ball is going to be slow. Glycerin, high viscosity, the ball is going to be slow. Water, low viscosity, the ball is going to be fast as compared to. So the fluid with the highest viscosity is II only. II only, which is water. So in answering questions like this, you have to be very careful. Let's move to question number 5. Question number 5 says, in extrinsic semiconductors, the dopants are, in extrinsic semiconductors, the dopants are A, host atoms, B, elements, C, impurity atoms, D, the holes. It is important to listen critically. When we say extrinsic semiconductors, there is a difference between extrinsic semiconductors and intrinsic semiconductors. Intrinsic semiconductors are pure conductors, and in intrinsic semiconductors, the number of holes is the same as the number of electrons. Remember, the holes are the positively charged, while electrons are the negatively charged. In an extrinsic semiconductor, another name for an extrinsic semiconductor is an impure semiconductor. And for an impure semiconductor means that the pure semiconductor is doped with a group 3 element impurity or a group 5 element impurity. So I'm saying this to say that when we talk about dopants, all right, we are saying that the dopants are the impurity atoms. Option A, holes, that's host atoms, that's wrong. Option B, elements. What kind of elements? That's wrong. Option C, impurity atoms. That is correct. Option C is the correct answer for question number 5. Let's move to question number 6. Question number 6 says, I, gas supplied to thermal stations, II, water level in dams, III, vandalization of electric cables. Which of the following can affect electricity supply in Nigerian homes and industries? Which of them can affect electricity supply? If you listen to what I have mentioned, you discover that everything I have mentioned can actually affect electricity supply in Nigerian homes. Gas supply to thermal stations. If there is insufficient supply of gas, there will be a problem. It will affect the electricity supply. When I was doing my industrial training in Ibom Power Company of blessed memory, sometimes when there's an insufficient supply of gas, the power plant will not be able to supply power to the national grid, and that will become a problem. So everything can be on set, but because there is insufficient supply of gas, that can affect that. The next, water level in dams. For hydroelectric power supply, that is the power supply that makes use of water to generate electricity. In such cases, if there is low supply level of water in dams, it may affect the power supply. Also, vandalization of electric cables. If electric cables are vandalized or destroyed by some non-patriotic citizens, that can, to a great extent, affect supply. So the correct answer, which I have here, is A, I, and I. All of those three options will affect. Question number 7. Question number 7 says, which of the following is true about a machine? Option A, efficiency is 0. Option B, efficiency is greater than 100%. Option C, efficiency is less than 0. Option D, efficiency is 100%. Which of the following is true? If you look at option D, efficiency is 100%. The efficiency of a machine cannot be 100% except that machine is an ideal machine. Option C, so D cannot be the correct answer. An ideal machine does not exist. Option C, efficiency is less than 0. Practically speaking, the efficiency of a machine cannot be less than 0. It cannot be less than 0. It cannot be negative. Option B, efficiency is greater than 100%. Also, in practical machines, efficiency cannot be greater than 100%. Option A, efficiency is 0. Yes, it's possible for the efficiency of the machine to be 0 if there is no work input and there is no work output. Question number 8. In changing a DC motor to an AC motor, that is in changing a direct current motor to an alternating current motor, what adjustments must be done? This is a very simple question found under generators, electromagnetic field. That's under electromagnetism, and magnets. All right. Option A, the position of the coil will be changed. Option B, the cross-sectional area of the coil is increased. Option C, the split rings are replaced with the slip rings. Option D, carbon brushes are replaced with the slip rings. Now, the correct answer to this question is so echoing. Make out a time to read that topic. When the split rings are replaced with slip rings, you will convert a DC motor to an AC motor. When split rings are replaced with slip rings, you will be able to convert that. Question number 9. So the correct answer is option C. Question number 9 says, the dielectric of a capacitor is used to. In question number 9, a capacitor is a device used in storing electric charge, and a capacitor practically looks like this. There is a gap in between a capacitor, and there is a distance in between connected to a cell. All right, this is Q positive, and this is Q negative. That's two metal plates. The gap in between the two metal plates, that gap is called the dielectric. It can be an insulating material or it's called a dielectric substance. The purpose of the dielectric is to store the charge. It prevents charges from crossing or jumping from one metal plate to another. So this gap accumulates the charges, provides an avenue for charges to be stored. So the question is, the dielectric is used to do what? Is it used to balance up the energy? Is it to regulate the current flow? C, is it to boost the voltage between the plates? D, increase the energy stored. Because the capacitor does the work of storing energy, the dielectric actually increases the energy stored. Let's move to question number 10. Question number 10 says, the speed of sound in air is independent of A, elasticity, B, density, C, pressure, and D, temperature. Which of those options is the correct one? The speed of sound in air is independent on. So which one does the speed of sound not depend on? If you look at that option, the speed of sound actually depends on density and actually depends on pressure. All right? It depends on temperature. It depends on temperature. So there are two correct answers in that question: density and pressure. That's B and C. So that is, should I use the word ambiguous? So density and pressure is independent. All right. So let's move to the next question. Like I said, these questions are consolidated. They are extracted. All right. They are just picked from the question bank for this particular year. Okay. Let's move. Question number 11. Question number 11. The dimensions of power are: A, is it ml square T square? B, is it ml square T raised to power minus 3? Option C, is it ml T raised to power 2? And D, is it ml T raised to power 1? So we are to find the dimensions of power. The dimension of power is simply get the unit of power from first principles and then extract the dimension from there. So from here, you can quickly see that power has the formula energy or work done all over time. From first principles, it is more preferable to use the mechanical energy, or should I say the formula for work done from first principles. Yes, let me prefer that. So because energy and work done have the same unit. So using force times distance all over time. Formula for force: mass times acceleration times distance all over time. So power is equals to kg, acceleration, meters per second raised to power minus 2, times the unit of this is meters all over seconds. Why am I using this formula to extract the unit? Because when I do this, I call it first principles to the very basic. It will help me to find the dimensions. This is mass. The dimension of mass, whose unit is in kg, is m. The dimension of meters of length, whose unit is meters, is L. This is seconds, whose quantity is time, dimension is t, raised to power minus 2, times this is meters, dimension is length, all over seconds, dimension is time. So this is m L times L is L squared T raised to power minus 2 divided by T raised to power 1. So the dimension of power is obviously ml squared T raised to power minus 2 minus 1, which is ml squared T raised to power minus 3. What happened here was indices playing out here. Minus 2 minus 1 gives us minus 3. All right. Moving forward from there, we are going to move to the next question. So option B is our answer. The next question, a very interesting question. Let's move. You can pause the video and look at it while I proceed. So number 11 goes like this, or number 12 rather. We just finished number 11. A man moves 20 meters north. A man moves 20 meters north. So from the point he moves 20 meters north, then 12 meters east. From the north to the east is 12 meters. And finally, 15 meters south. Finally, 15 meters south. 15 meters will not be as long as the 20 meters. So I'll sketch something like this. So let's say this is 15 meters. And you can see that if I complete that rectangle, the remaining is 5 meters. But this is where the man stopped. A man moves 20 meters north, then 12 meters east, and finally 15 meters south. His displacement from the starting point is now, so 20 meters, 12 meters, 15 meters. Displacement from the starting point. This is the starting point O. Displacement from the starting point is this. And displacement from the starting point gives me, it just demands that I find the distance between this point and this point. First of all, look at it critically. You discover that this is 12 meters. If this is 20 meters, it means that this is 5 meters. To find this displacement, I would just quickly see that I'm having my right angle triangle. I can extract my right angle triangle, or I extract this other right angled triangle. So there are two identical triangles there. I can take any of them and I get my answer. So this is 5 meters, this is 12 meters. So what would this 5 meters, if this is 12 meters, that means this is also 12 meters. So what will be my hypotenuse? If you look at that, we'll apply Pythagoras theorem. From Pythagoras, we'll have that what? 5 square plus 12 square equals to x square. Let's say we're looking for x. X is the displacement from the starting point O. So 5 square is 25 plus 12 square is 144 equals to x square. So 25 plus 144 is 169 equals to x square. Take the square root of both sides. 169 equals to x square. Take that square root. So this is 13 equals to x. So x is equals to 13 meters. So the displacement from the starting point O is actually 13 meters. 13 meters. All right. Let's move to the next question. The next question said, in the circuit above, what is the capacitive reactance? If you look at that question critically, failure from some extractions, there was no diagram. So we are just giving options and they were not given a diagram to use to calculate. I can't tell if practically JAMB will give this as a bonus. They will decide. But like I said, these questions are extracted. Typographic errors are inevitable. Let's move to question number 14. The angle between the geographic north and the magnetic north is the angle of A. Zenith, B. Magnetic meridian, C. Dip, and D. Declination. This is under magnetism. This question is under magnetism. The correct answer is the angle of declination. Check what angle of inclination is. It is the angle between the geographic north and the magnetic north. You can read full details on that topic in your physics textbook to get yourself updated. Let's move to question number 15. Question number 15 says, in photoelectric effect, the kinetic energy of photoelectrons depends on. This question is under a topic called quantum physics. Quantum physics under energy quantization, specifically energy quantization. We'll be looking at photoelectric effects, we'll be looking at Planck's constant, we'll be looking at work function. So please read it up. These are one of the areas you may encounter questions from. So the question is, the kinetic energy of the photoelectrons depends on A. Phase angle of incident radiation. No, it doesn't depend on the first angle. B. Velocity of incident light. No, incident radiation. It does not depend on the velocity. That may sound strange, but that's true. Read it up. You're going to see that. C. Frequency of incident radiation. And D. Density of incident radiation. The correct option is C. Frequency of incident radiation. Please read up that topic in your textbook. Question number 16. An object moves in a circular path of radius 0.5 meters. So, I am being given radius of 0.5 meters for an object moving in a circular path with a speed of 1 meters per second. That speed is V, interchangeably used as 1 meter per second. What is the angular velocity? What is the angular velocity? Meanwhile, it's important to note that linear velocity V is equal to angular velocity times R, that's WR. That means that angular velocity W is equal to, divide both sides by R, so I will have that W equals to V all over R. From there, we will quickly find the angular velocity. Angular velocity W is V, which is over R, which is 1 all over 0.5. 1 divided by 0.5 is something as 1 all over half, which is 1 times 2 over 1, which is 2 over 1 rad per second. 2 over 1 rad per second. In case you do not know, the unit of angular velocity is in rad per second. Meanwhile, if you encounter any problem, even though this is not a live video, you can drop your questions at the comment section. Make sure you comment, make sure you like, make sure you share. Question 17. What effort will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its load arm? Smartness comes in here. If its effort arm is twice as long as its load arm. Effort arm simply means distance moved by effort, denoted as small letter E. Load arm simply means distance moved by load, denoted by small l. Meanwhile, it's important to note that mechanical advantage is capital letter L all over big letter E. Capital letter L is the load itself. Capital letter E is the effort itself, most times represented in Newton. So, while the small letter L is the distance that is moved by this load, small letter E is the distance that is moved by this effort. And velocity ratio, alright, equals to E over L. Velocity ratio is the effort arm divided by the load arm. Moving progress, we are to find the effort. we don't know what effort is. So I have been given efficiency as 90%. The next given is that I have been given a load of 180 Newton. The next is that I have been given I think that is all I am given. That is all I am given. So, solution. To find the solution to this question, I would make use of this. Formula for efficiency. Efficiency is MA all over VR times 100. Meanwhile, I hope you know that there is a way we can find efficiency using work input and work output. Please go and read that up. You don't know the question that may come in your own year, and time is very important. So efficiency 90 equals to my MA is L over E all over my VR. My VR is E over L. Don't forget that the value of E is what? 2L all over. My value of L is L. This should suggest something to you. What this should suggest to you is that if L cancels L, I am gone. That the velocity ratio is 2. L over E all over 2 times 100. Now watch this. You can still decide to say the velocity ratio from here is what? E, and my value of E was what? 2L all over L. You could have still ended it here, such that mechanical advantage over VR, you just put into there at once. So this will be 90 equals to L over E divided by 2 times 100. 90 equals to L over E, all right, times 1 over 2 times 100. So from there, I'm going to cross multiply, and when I cross multiply, I'm going to have something very interesting. Cross multiplying from there, I have 90 E times 2 equals to L times 1 times 100 is 100 L. That is the load you were supposed to find. And from there, if I divide both sides by L, 100, divide both sides by 100. Meanwhile, we are looking for the effort. L times 1 times 100 is 100 L. So, I have, but just before then, we need to bypass a step before then, before we divide both sides by 100. I want to find the effort. I was given the value of L as 100. So this is 90E times 2, 180E is equals to 100 times 180. So at the end of the day, that's what is going to happen. Dividing both sides by 180 to find E. So effort is 180 cancels 180. So what I have there is 100 Newton. So the correct answer is A, which is 100 Newton. Let us move to question number 18. Question number 18. Question number 18 says that a man walks 1 kilometer due east. A man walks, so from a point, 1 kilometer due east. East is to your left. So that was 1 kilometer. And the next, and then 1 kilometer due north. So from here, he walked another 1 kilometer due north. 1 kilometer. And his displacement simply means what is the distance from the starting position. It will interest you to know that on the Cartesian plane, or in my cardinal point, this is where I find this illustration. This is my hypotenuse from a right angle triangle that I can see here. So my hypotenuse being x, so 1 square plus 1 square equals to I want to find x. So this is 1 plus 1 equals to x squared. This is 2 equals to x squared. Take the square root of both sides. If you take the square root of both sides, I would see that x is equals to root 2. What I have is root 2 is equal to x. So x is equal to square root of 2. So this is square root of 2. Remember, you are to find is displacement. Displacement is distance in a specified direction. In what direction is this? This is my north and this is my east. Moving from here, we can say, let's check how our options looks like. Option A, root 2 kilometers north 45 degrees east. Option B, 1 kilometer north 30 degrees east. Option C, 1 kilometers north 15 degrees east. Option D, root 2 kilometers north 60 degrees east. So I need to choose an answer that have north and east, northeast. And those answers are, I think almost all of them as northeast. Now, to find the angle will be, if this is 1 and this is 1, that means that this is a isosceles right angle triangle. That means this will be 45 degrees. This will be 45 degrees. If this is 45 degrees, because these two sides are equal, that means these two angles must be equal. And that value must be 45 degrees. That means that this angle is also 45 degrees. Also 45 degrees. So that 45 plus 45 will give me 90. So root 2 kilometers northeast. Northeast. Alright. We move from number 18 to question number 19. So the density of 400 cm cube of palm oil was 0.9 gram per cm cube before frying. If the density of the oil was 0.6 gram per cm cube after frying, its new volume is, don't forget that density is mass all over volume. We have a situation before frying and we have a situation after frying. So before frying, we have a density. So let us term before and after. V1, that's what I'm with the volume. V1 before frying, after frying. Alright, so V1, that's before, 400 cm cube was 0.9. So the density before was 0.9 gram per cm cube. Now, after frying, assuming that no quantity of oil was left, what this means is that assuming that the mass of the oil remains constant, you are told that its density, that's D2, now become 0.6 gram cm cube. Now, from here, we are asked to find its new volume. We are asked to find V2. Assuming no loss of oil due to spilling. This means that no loss of oil due to spilling means that if density is mass over volume, if the mass is constant, so dV equals to m, and m is equals to dV. If you remember your gas laws very well, you see that m, which is a constant, is d1 v1 equals to what? D2 v2. So we're going to apply this principle so that we can find v2. So d1 was what? Using d1 v1 equals to d2 v2. This is telling us that mass is constant. No spill of oil. The mass or the quantity is intact. D1 was 0.9 times V1 is 400 equals to D2 is 0.6 times V2. So to find V2, I'll divide both sides by 0.6. That cancels out. To find V2 will be equal to that. 0.9 times 400, 0.9 times 400 will give me 360 all over 0.6. All over 0.6. If you do that division correctly, you would see that that is equals to V2. So 360 divided by 0.6, that quickly gives you 600 cm cube. Or you say that V2 is 600 cm cube. The correct answer there is B. Question number 20. Question number 20 says, which of the following is true of an electrical charge? A, positive charge means deficit electrons. For a positive charge, it means there are less electrons and more protons. Which of the following is true? B, negative charge means excess electrons. Negative charge for an ion, for instance, it means that the electrons are excess. Which of them is true? Option C, electric current means movement of electrons. Yes, of course, electric current means movement of electrons. And option D says all of the above. So the correct answer is D, which is all of the above. Question number 21. Natural radioactivity consists of the emission of A, alpha particles and beta particles, B, alpha particles and X-rays, C, alpha particles, beta particles and gamma rays, D, gamma rays and X-rays. The perfect option there is C, alpha particles, beta rays and gamma rays. Supposed to be beta particles, most preferred. Question number 22. Which of the following does not describe the image formed by a plane mirror? Which of the following does not describe the image formed by a plane mirror? A, literally inverted. Image formed by a plane mirror is literally inverted. B, same distance from the mirror as object. Image formed by plane mirror is same distance from the mirror as the object. D, magnified. If you stand before yourself in the mirror you have in the house, do you look bigger in the mirror than you actually are? No, it is same size. So for a plane mirror, image is not magnified. So the correct answer is D. Which of the following does not describe? Does not describe. Question number 23. Which of the following best describes the energy changes which take place when a steam engine drives a generator which lights a lamp? A steam engine is driving a generator. What happens first is that the steam engine makes use of heat, and that heat is converted to kinetic energy. That's the movement of the rotor of a steam engine. The rotor of the steam engine moves, all right, that's mechanical energy, and on the strength of that rotation, the mechanical energy is converted to, that's the mechanical energy which is kinetic, is converted to electrical energy. Before we now have heat and light. Option B is the correct answer. Question number 24. Cathode rays are what? Cathode rays are what? If you've read about cathode ray oscilloscope, which I expect you to read under a topic called, I think it's still under photoelectric emission, thermionic emission, around that or thereabout, you are going to see this. That cathode rays is not high energy electromagnetic waves. Cathode rays is not protons. Cathode rays are not neutrons. But cathode rays are streams of electrons. Question number 25. A narrow beam of white light can be split up into different colors by a glass prism. The options are presented before you. You can see option A. The correct explanation is that a white light is an electromagnetic wave. That is not a very perfect explanation. The prism has all the colors of white light. That's not the perfect explanation. Option C, different colors of white light travel at different speeds in the glass. That is correct. Option C is the answer. And option D, white light has undergone total internal reflection. No. Total internal reflection has to do with the critical angle when, no, that is not the perfect answer here. So the answer is C. Different colors of white light travel with different speeds in glass. Question number 26. The ray which causes gas molecules to glow is known as, even if they had woken you up from sleep, you would answer this one. The ray that causes gas molecules to do what? To glow. That ray is what? Is cathode rays. It's not gamma ray, it's not molecular ray, it is not anode ray, but cathode ray. Option C. Question number 27. Which of the following materials is a conductor? Look at the options. You can be woken up from sleep too, you should answer this question. A. Sodium. B. Glass. C. Plastic. D. Wax. Of course, sodium is the only metal there which is a conductor. Question number 28. Question number 28 is a question that we did in one of our topics that was on semiconductors. So you can watch our videos on semiconductors to be well grounded about this. Question number 28 says, a silicon material is doped, that's doped, addition of impurity, with an element of a certain group, and an N-type semiconductor is formed. The most likely group of the elements is for an N-type semiconductor to be formed, an intrinsic semiconductor or a pure semiconductor is doped with a group 5 elements. So the correct answer is D. A, group 1, B, group 2, C, group 3, D, group 5. The correct answer is D. Question number 29. When impurities are added to semiconductors, the conductivity of the semiconductor A increases, B decreases, C remains constant, D increases then decreases. The reason for the addition of impurities is to increase the majority carriers. And when majority carriers are increased, conduction does what? Increases. So the correct answer is A, conductivity increases. If you check my video on semiconductors, things will be much more clearer to you. Question number 30. The current in a reverse bias junction is due to, if you look at a reverse bias junction, for a reverse bias junction, there is so much resistance in the circuit. And because there's so much resistance in the circuit, there is low what? Current. So the low current is as a result of the minority carriers. Remember, the majority carriers brings about conduction. So reverse bias, low current, and the low current is as a result of minority carriers. The correct answer is C. A, majority carriers. No, majority carriers is for forward bias. B, holes. C, minority carriers. And D, electrons. The correct answer is C. Let's look at question number 31. If you look at question number 31, it says the stylus of a phonograph record exerts a force of 7.7 times 10 raised to the power minus 2 Newton on a groove of radius 10 raised to the power minus 5 meters. Compute the pressure exerted by the stylus on the groove. A groove is a circular base. A groove is a circular base. What I mean is that that groove has a radius. Yes. You have to calculate the pressure exerted on that circular base by a force of 7.7 times 10 raised to the power minus 2 Newton and a radius of 10 raised to the power minus 5 meters. Pressure is force over area. From the radius, area is pi r squared. That means pi times r, that's 10 raised to the power minus 5 all square. This means pi times 10 raised to the power minus 5 all square is 10 raised to the power minus 10. Some persons will say 100 raised to the power minus 25. I'll be 100 raised to the power 25. That's wrong. So my area is pi times 10 raised to the power minus 10. So my force was 7.7 times 10 raised to the power minus 2 all over pi times 10 raised to the power minus 10. Doing that critically, my pi is 7.7 divided by 3.142 times 10 raised to the power minus 2. This is 10 raised to the power minus 10. So we are going to do that quickly. And from there, 7.7 divided by 3.142, if you do your calculations very well, you're going to have 2.45. So this gives me 7.7 divided by this, 2.45, and this is times 10 divided by minus 2 divided by 10 divided by 10 raised to power minus 10, 10 raised to power minus 2 minus 10. So this gives me that the pressure is 2.45 times 10 raised to power minus 2 plus 10. That is 2.45 times 10 raised to power 8. 10 raised to power 8, what? Unit of pressure is Newton meter square. So if you look at this, you would agree with me that force is Newton divided by area is meter square. So that's my pressure. The correct answer is C. You can compare the options and you see that we learn as option C. Question number 32. Question number 32 says, a piece of stone attached to one end of the string is whirled round a horizontal circle and the string suddenly cuts. The stone will fly off in a tangential direction. Compare your option. Option A, tangential to the circular part, correct. Perpendicular to the circular part, wrong. Towards the center of the circle, wrong. Parallel to the circular part. Option A, tangential. Question number 33. Question number 33 says, the phenomenon whereby the water droplets in the atmosphere combine with dust particles in the air to reduce visibility. To reduce visibility is called A, fog, B, hail, C, mist, D, cloud. Now, of course, one of the ways of answering questions is that you look at the question and then you know that this cannot be the answer, this cannot be the answer. The answer can be either this or this. If you look at cloud, cloud is far beyond the lithosphere. That's the part where we exist, all right, or we occupy rather. So it cannot be D, it cannot be cloud. If you look at hail, no, it can't be hail, all right. So we have either fog or mist. Now, fog is a very severe case of mist. So in cases of mist, visibility is reduced, but in cases of fog, it is very severe. So fog is a severe case of mist. So for that question, to reduce visibility, the perfect answer is mist. Fog is a very severe case of mist. Question number 34. We have 6 questions to go. A quantity of water at 0 degrees Celsius is heated to about 30 degrees Celsius. The quantity of water at 0 degrees Celsius is heated to about 30 degrees Celsius. At each degree rise in temperature, its density will, at each degree rise in temperature, its density will A, rise steadily, B, rise then fall, C, fall steadily, D, fall then rise. I want you to know that density is equals to mass over volume. And at constant mass, we have that density is directly proportional to 1 over volume. What happened here? I am taking it that mass is constant. If I change the proportionality sign, that goes. So this means that the higher the density, the what? Lower the volume. Back to the equation. A quantity of water at 0 degrees Celsius. So from 0 degrees Celsius, water is heated to about 30 degrees Celsius. There is something called anomalous expansion of water. Anomalous expansion or behavior of water. At 4 degrees Celsius, between 0 degrees Celsius and 4 degrees Celsius, water will tend to, should I say, contract. All right. Before I talk about that, from 100 degrees Celsius, if you reduce the temperature of water, water will contract in this direction. When it reaches 4 degrees Celsius, instead of contracting, water will begin to do what? Expand. From this point, it will begin to expand. From 0 degrees Celsius, if you heat it, water will begin to contract. So in this direction, water will contract. And from 4 degrees Celsius, water will begin to do what? Expand. It's called anomalous behavior. If water is contracting from 0 to 4 degrees Celsius, that means that the the volume is what? Reducing. The volume is reducing. So if the volume is reducing, density will be doing what? Increasing. So as the water is contracting between 0 and 4 degrees Celsius, volume reduces, and what happens to density? Density increases. I'm sorry that I have to write that inside. As volume reduces, density increases. Now, from 4 degrees Celsius, as you keep heating to 30 degrees Celsius, even if you're not reach 100, what will happen there is that water will begin to do what? Expand. If water expand, that means that volume increases. If volume increases, that means that volume increases. That means that what happened to density? At that point, density decreases. So you can see that the density will do what? Rise. And after some time, the density, after rising, is going to fall. So the correct answer is B, rise, then fall. Question number 35. Question number 35 says, a thin wire with heavy weight attached to both ends is hung over a block of ice resting on 2 supports. If the wire is cut through the ice block while the block remains solid behind the wire, the process is called what? A, fusion, B, sublimation, C, condensation, and D, regulation. The correct answer is regulation. That is option D. And I'm going to show you how that works. If I have a block such that wire is hanging on it, so this is on the other side. If pressure is applied, this is a weight, and this is another weight. This is ice. What will happen is that if pressure is applied, this thin wire will cut through this ice, and immediately it cuts through this ice, the part that was cut will freeze again. That process is called regulation. Question number 36. A cell of internal resistance 0.01 ohms can be measured accurately using what? It can be measured accurately using a potentiometer. Why? A potentiometer is a 3-terminal resistor with a sliding or rotating contact that forms an adjustable voltage divider. A potentiometer is more preferred because if you don't use a potentiometer, if you use a voltmeter, it would draw some current from the cell leading in voltage drop. So potentiometer is most preferred. Question number 37. Question number 37 is another interesting one. Says an electron of charge. So if you look at the question, what I am given is charge, which is 1.6 times 10 raised to power minus 19 coulombs. And I'm given mass, which is 9.1 times 10 raised to power minus 31 kg. Accelerated between 2 metal plates of velocity 4 times 10 raised to power 7 meters per second. The potential difference between the plates is, potential difference is also denoted as voltage. What will be my potential difference between the plates? Having examined the parameters given in the question, we can simply proceed in solving that question number 37. We should recall that in general, if a charged particle is accelerated between 2 metal plates or region of the charge, The work done on the charge is given by the product of the charge and the potential difference. Work done is given by product of the charge and the potential difference. This is charge and this is potential difference. If we are looking for the potential difference, it means that the potential difference V divided both sides by Q is W all over Q. It means that the potential difference is that. Meanwhile, it is also important to note that this work done is also the kinetic energy. Yes, for a charged particle that is accelerated between two metal plates. Yes. What does this suggest to us? It suggests to us that if V is equals to W over Q, V is also equals to kinetic energy all over Q. So V will be half mv squared all over Q. So this is equals to half times m, which is 9.1 times 10 raised to power minus 31 times v squared 4 times 10 raised to power 7 all square all over Q. Q is 1.6 times 10 raised to power minus 19. So V is, this will cancel. Of course, you have 4.55 times 10 raised to power minus 31 times, if I square this, it will be 16 times 10 raised to power 14. Please take note. I square 4, I add 16. Square 10 raised to power 7. It will not be 100 raised to power 49. No. 10 raised to power 7 all square. 7 times 2 is 10 raised to power 14. Take note of that. Taking note of that, this is all divided by 1.6 times 10 raised to power minus 19. So what I will do to make things easier for me, I would say 4.55 times 10 raised to power minus 31 times 16 times 10 raised to power 14. Meanwhile, this is not what I wanted to do. I wanted to pick 4.55, pick 16, all right? And yes, so let's do that now. 4.55 times 16 all divided by 1.6. What am I doing? I want to pick the terms without index. And then the terms with index now times 10 raised to power minus 31 divided by 10 raised to power times 10 raised to power 14 divided by 10 raised to power minus 19. I know what I'm doing, all right? So if I do this over here, I'm simply going to have, all right, 1.6, check what is happening here. 1.6 can go into 16. 1.6 can go into 16. That will be 10 times. You're not seeing it, you'll see it. 1.6 times 10 will give me 16. So that can go. So what I have left is 4.55 times 10 raised to power minus 31 times this, so it will be plus 14, all divided by 10 raised to power minus 19 minus 19. I'm applying indices there. So this will be 4.55 times 10 raised to power 1 times minus 31 plus 14, 10 raised to power minus 31 plus 14. Of course, minus 31 plus 14 is going to give me minus 17. Minus will be plus 19. So minus 31 plus 14 would give us minus 17 plus 19. So that will be 4.55 times 10 raised to power 1 times 10 raised to power 2 times 10 raised to power 2. All right. So if you look at that critically, you discover that we are almost there. And moving from there, we have 4.55 times 10 raised to power 3. 4.55 times 10 raised to power 3. Meanwhile, we need to check a figure there. Let's pick our calculator and check so that we will be sure of what we are doing here. So checking this up, all right, so this is correct. Okay, this is correct. And this is correct. Okay, 10 raised to power 1 times 10 raised to power 2. All right. So the potential difference is 4.55 times 10 raised to power 3 volts. That is option D. So we just have 3 questions to go. Number 38, 39, and number 40. Question number 38 says, a 90 cm uniform lever has a load of 30 Newton. So the lever is uniform and the length of that lever is 90 cm. Has a load of 30 Newton suspended at 15 cm from one of its ends. Let me pick this as one of its ends. So from one of its ends, if I call this B, A, so 15 cm from one of its ends, I will have a load of 30 Newton. So this length that I have here is 15 cm. Remember that everything is 90. Everything is 90. If the fulcrum is at the center of gravity, because this is uniform, 90 cm, the center of gravity will be at the midpoint. And the midpoint is at 45 cm. So if I call this the fulcrum, which is a fixed point which can rotate or move freely, so this is 45 cm and this is 45 cm. What does this mean? What's the implication of this? The implication of this is that this will be my reference point. From there, the force that must be applied to its other end, the other end, which force must be applied to this other end? F. That will keep this in equilibrium is, so if this is 15 cm, that means that this is what? 45 minus 15, that will give me 30 cm. You can convert this to meters. Even if you don't convert it, since it's an equation, it's going to cancel out. So if I convert it, this is the force. So moment, so we have clockwise moment and we have anti-clockwise moment. Using the principle of moment, from the principle of moment, clockwise moment is equals to anti-clockwise moment. The clockwise moment would be this force, which is what I'm looking for, times the distance between this force and the fulcrum is F times 45. Even if you don't convert, moment is force times distance, is equals to the anti-clockwise will be 30 times the distance between this and the fulcrum is also 30 cm. To find force, I'll divide both sides by 45. Note that moment is force times distance. Same as work done. Alright? So that is F is equals to 900 divided by 45. If I divide 900 by 45, divide 900 by 45, you can pick up your calculator and check it out. 900 divided by 45, yes, 20. So that force will be equals to 20 Newton. So it will be a 20 Newton force that will balance this uniform meter rule. Let's move to question number 39. On top of a spiral spring of force constant, 500 Newton meter. Force constant 500 Newton per meter. Is placed a mass of 5 times 10 raised to power minus 3 kg. If the spring is compressed downwards by a length of, that's compression for x, 0.02 meters, and then released, calculate the height to which the mass is projected. In bracket, you're given g as 10 meters per second. You can check the options there before we are to solve this. So imagine a spring, and we are told that this spring has a force constant K as that, and a mass of this kg is placed on it. Let's say this kind of mass is placed on this spring. Mass is placed on it. And then this mass does what? Compresses this string. Maybe compress this string to a point that the compression of this string is compressed by 0.02 meters. That's the compression. All right, the length is shortened by 0.02 meters. All right, this is my compression, 0.02 meters. Now, I hope you know that this compression is happening at a particular height under gravity. Originally, the energy in this string is called elastic potential energy. And the elastic potential energy of the string, in this string, when you compress it, when you leave the string, what is going to happen is that the mass will be what? Projected. So you have to calculate the height to which the mass is projected. The elastic potential energy will be compared to gravitational potential energy because the mass will be projected through a height. Gravitational potential energy, that is mgh. Elastic potential energy is given as half ke square. Let me use x for compression. Half kx square. So half times k. My k was 500 times x square. X is 0.02 all square. So that is in meters already, no need to convert. Equals to mgh. My m is 5 times 10 raised to power minus 3 times my g is 10 times my h is what I'm looking for. So from there, I can now say that h will be, simplifying what I have there, half times 500 will give me 250 times 0.02 all square is 0.04 0.0004, yes, equals to this times 10, that will be 5 times 10 raised to power minus 2. What happened here was 10 raised to power minus 3 times 10 raised to power 1. You add the powers. Minus 3 plus 1, is minus 2 times h. So if I divide both sides by 5 times 10 raised to the power minus 2, divide both sides by 5 times 10 raised to the power minus 2, so that cancels. So I need to simplify this side. So you can see it here that 250 divided by 5, 250 divided by 5 is 50. 5 goes here 1, 5 goes here 50 times, this is the same thing as in standard form, 4 times 10 raised to the power minus 4. 1, 2, 3, 4 minus 4 divided by 10 raised to the power minus 2. This is equals to h. From there, I have 50 times 4 times 10 raised to the power minus 4 minus 2. That will give me equals to h. So that is 50 times 4. 50 times 4 quickly gives me 200 times 10 raised to the power minus 4 plus 2 equals to h. So this is 200 times minus 4 plus 2 equals to minus 2. And of course, equals to h. Of course, this is 200 times 1 over 10 square. I just applied my indices, so I remove the negative sign. Equals to h. So this is 200 times 1 over 100 equals to h. That's 200 over 100 equals to h. So that cancels. So you can say that h is equals to 2. H is equals to 2 meters. That will be the height in which that string, that mass will be projected. I hope that is clear. Meanwhile, you can always drop your questions on any part of these questions which you don't understand. Clarity will be made. Question number 40. This question is very interesting. The question says, a hose of cross-sectional area 0.5 meters square is used to discharge water from a water tanker at a velocity of 60 meters per second in 20 seconds into a container. If the container is filled completely, the volume of the container is, remember, whatever you're doing, you want to find the volume. Watch this. You are given the area of this hose as 0.5 meters square. And you are also given the velocity of 60 meters per second. And the next is that you're given time is 20 seconds. You're asked to find the what? The volume. The volume must be in meters cube. Take note that area this is velocity, volume in meters cube is area times velocity times time. I can prove it to you. Area is in meters square, velocity is in meters per second, and time is in seconds. This is something as meters square times meters divided by second times seconds. So you can see this, that meters square times meters is meters cube. That means that if I must find the volume, I need to multiply all those parameters. So the volume is equals to area times velocity times time. My area was 0.5, velocity was 60, time was 20. 0.5 times 60 is 30, times 20, 30 times 20, that's 300 times 2. So the volume is 600 cm cube. 600 cm cube. Thank you so much for staying till the end. And it was looking as if you will not stay. If there is anything you should do right now, is go and click a like. The fact that you watched this video over an hour now, go and click a like, go and make a comment, go and click a share. And if you're not subscribed to this channel, Be careful. See you in the next class. Thank you so much. This is Learn with Master. Stay tuned in this channel where more interesting videos will be coming up to you on JAMB related topics, WAEC related topics. Thank you. See you in my next class.